Science Unit 7, Part 5. Today, please turn to page 9, and we're going to start at the top of the page, and we're going to go into a little more detail now about Charles Darwin's theory of evolution by natural selection. So this is the top of page 9. There are 5 principles of evolution by natural selection. You have seen some of this referenced in the previous videos and stuff that you've been watching. So first of all, the first principle is that organisms are always going to produce more offspring than can survive to adulthood. So in some cases that might mean right off the bat, like these sea turtles. Unfortunately, these little baby sea turtles, probably about 98% of them aren't going to last more than a couple of days in the ocean. So many of them are going to die off. And so the sea turtle is always going to lay lots and lots of eggs to have lots and lots of offspring because there's only a few that are going to actually survive. Now, there are variations that occur among individuals in a species. They're not all the same. So within a species, you're going to have a lot of things that are similar, certainly enough that makes them the same species, but there's going to be some things that are going to be different from one member to the next. And those variations then are part of their DNA, and they're going to be passed on to their offspring. Okay, so the variations might be something as simple as like hair color, or it could be something that actually is going to help the person or the organism survive better in their environment. So by definition, a variation is an inherited trait that makes an individual different from members of its species. Still the same species, still lots in common, but some differences that may or may not affect its survival. All right, so some of those variations then are going to be helpful. And by helpful, we mean that they are able to survive better in their environment. So those individuals with the helpful variations are going to be more likely to survive and more likely to reproduce. So the ones that have the helpful variation for survival are going to be most likely the ones that are going to live long enough to be able to reproduce and pass those variations on to their offspring. Now, when we have a helpful variation, a variation that makes an organism better suited to its environment, we call that an adaptation. An adaptation is any variation that makes an organism better suited to its environment. Okay, now those can take a lot of different forms. One example to show you, if you look at these bunnies. So you can see that this bunny right here is in the wintertime white, which you can see actually would help it blend into its environment and hopefully help it survive better. If that color that they have provides camouflage for them and allows them to survive better, we would call that an adaptation. Now here you can see in a different environment that white bunny would stick out, but you can see the bunny in this environment has the helpful variation of the fur color that allows it to blend in with its environment and provide camouflage for it. So over time, the offspring of individuals with the helpful variations are going to be making up more and more of a population because they are going to be the ones that keep surviving and keep producing offspring. Eventually, the organisms in the population look and behave differently enough to be recognized as a new species. Okay, now you have a blank in your notes at this point. And this entire kind of concept that we're talking about, all of these variations, is often summed up in the phrase survival of the fittest. So that's what I'd like you to write on that blank. I'd like you to copy this phrase down. It's a really common phrase you'll hear people say, you'll hear used to describe natural selection. So I want you to have that in there, survival of the fittest. Okay, now I have a great little video about salamanders that shows this exact process I'm going to show you. The sound is not great on this video, but I think it does a really great job of explaining, so just listen carefully and pay attention to how we end up having new species of salamanders formed because of this process.
type of terrestrial salamander found in California. Now meet another, and another. These salamanders are members of the same species, so why do they look and behave so differently? In California, populations of these salamanders became separated geographically, evolving over millions of years to adapt to different environments. They've changed so much that they are on their way to becoming entirely separate species. David Wake of the University of California, Berkeley explains.
The history of this species complex began about 10 million years ago in the ancient redwood forests of northern California, where we have today this form Picta, which is highly variable both genetically and in terms of coloration. There were two migratory routes followed by animals as they moved into southern California. One along the Sierra Nevada mountain chain, where animals moved into the forest region, the other along the coastal mountains. They avoided the Great Central Valley.
The populations that gradually moved down the forested region of California relied on blending in with their environment. Animals with good camouflage tended to survive more and produce offspring with similar traits. As the salamanders progressed south over millions of years, the markings became more distinct.
At the end of the chain in Southern California, we have this form Claveri, which is the extreme of variation, showing the largest blotches, most bold marking. These were all then camouflaged organisms that were hiding from predators. Along the coast, a different strategy was followed. Here, the organisms adopted the color pattern and behavior of dangerously poisonous newts, and they became, instead of camouflage, they were advertising their resemblance to these dangerously poisonous animals and gaining an advantage because of their mimicry. So what happened is that you had two differently adapted lineages moving to the south, and by the time they reached the southern end, they had essentially evolved into different species. But at certain areas, for example, in the Palomar Mountain areas in San Diego County, we get these animals which are hybrids, and the hybrids are neither similar to the dangerously poisonous animals, they're not good mimics, nor are they good animals in terms of camouflage. So these organisms are essentially dead ends.
These hybrid offspring are not well adapted to their environment and are therefore less likely to survive. The two parent subspecies that produce the hybrids are well on their way to becoming entirely separate species, evolving just as Darwin described in his theory of evolution.
I think Darwin would love this example because it shows exactly the sorts of patterns that he was talking about. Gradual adaptive divergence, leading eventually to the establishment of new species.
All right. So back to your notes now on page 9. The last definition way down at the bottom is for artificial selection. Now, artificial selection is also called selective breeding, which is why I have that in parentheses for you. And you might remember talking about this when we were doing the science of dogs in our genetics unit. Artificial selection is the process of breeding plants and animals for particular genetic traits. So examples, breeding dogs for speed, herding, or attitude. All of that dog breeding is an example of artificial selection. Now, one way to remember the difference here would be that natural selection happens on its own out in nature. Artificial selection happens because humans decide to have it happen. And so that's a major difference there. It's trying to mimic what happens in nature naturally. All right. This is the end of part